Hey algebra students! Tonight we're going to learn how to solve systems of equations algebraically. We have here a system, y equals 2x squared minus 8x plus 6, and y equals x plus 2. We already learned how to solve a system graphically. We can graph these two equations and look for their point or points of intersection. Each of those intersections is going to represent an xy coordinate pair that is a solution to the system. So let's go ahead and graph these two equations. Y equals x plus 2 is in red, and y equals 2x squared minus 8x plus 6 is this parabola in blue. One of the intersections here is pretty easy to spot on the graph. There's an intersection where x is 4 and y is 6. So the pair 4, 6 is a solution to this system of equations. But the second intersection is harder to spot on the graph. I can see that my x value is between 0 and 1, and my y value is between 2 and 3, but I can't really spot the exact decimal or fraction value of the solution on the graph. I need to solve this system algebraically. We've solved systems of equations algebraically before. Last year, you solved systems of linear equations using substitution. Quadratic linear systems can also be solved algebraically using substitution. Remember that to use substitution, you must have isolated a variable for at least one of the equations. But now that we're doing systems of equations with quadratics, we're going to try to make things easier on ourselves, and we're always going to start out by getting both equations set to y equals. For this first example, that's been done for us. Both of these equations start with y equals, so step 1 on our 4-step list is checked off. That means we're ready to start step 2, set the equations equal to each other. X plus 2 is equal to y, and 2x squared minus 8x plus 6 is also equal to y. That means that they can be set equal to each other. We're going to create a new equation, x plus 2 equals 2x squared minus 8x plus 6. We're ready now for step 3, bring equation to standard form. In order to do that, we need to get one side of this equation set equal to 0. We can subtract 2 from both sides, giving us x squared equals 2x minus 8x plus 4, and then we'll subtract that x as well. We've got to subtract it from its like term on the other side, and that gives us 0 equals 2x squared minus 9x plus 4. We have now a one-variable equation in standard form, which we can solve either by factoring or by the quadratic formula. Let's start solving this one by factoring. The first thing that we're going to do is look to make sure we don't have a GCF. Unfortunately, there's no common factor between 2x squared and negative 9x and 4. Since we can't factor out a GCF, and our a value is greater than 1, this is one of the trickier ones to factor, but we can do it. We're going to start by multiplying our a value and our c value. 2 times 4 is 8, and we've got a b value of negative 9. That means we're looking for two numbers that multiply to make 8 and add up to make negative 9. If we think about that for a moment, we can say negative 1 times negative 8 gives us positive 8, because a negative times a negative is a positive. And negative 1 plus negative 8 gives us negative 9. So that works out. Now that we've got those two numbers, we're going to use them to break our equation into 4 terms instead of 3. We're going to leave our 2x alone. And our 2x squared rather. And we're going to leave our plus 4 alone. But that middle term of negative 9x, we're going to break into negative 8x and negative 1x. Which I can do because negative 8x plus negative x is negative 9x. So I haven't changed the value of my equation at all. I've only broken the pieces up. What I'm going to do now is find a GCF for each set of 2 terms in my equation. So if I look at 2x squared minus 8x, I can pull out a GCF of, 2, and from x squared and x, I can pull out an x. So my greatest common factor between 2x squared and negative 8x is 2x. If I pull out that GCF, I'm left with x minus 4, and I can just quickly check that. 2x times x is 2x squared, 2x times negative 4 is negative 8x. That checks out. Now I need to pull out a GCF on the other side from my other two terms. Here's the trick. It needs to leave me with the same parentheses. So negative x and positive 4 don't really have a GCF, but if I want to end up with x minus 4 in the parentheses, I can pull out a negative 1. I've pulled a GCF out of both of those pieces, out of both sets of terms. So that x minus 4 that came up in both sets of parentheses is one of my factors for this equation. The other factor is made up of those two GCFs that I pulled out, 2x minus 1. We did it. We factored our equation, and that is still equal to 0. Which is important because the factors aren't enough. We don't just want factors, we want solutions. We can go back to that zero product rule and set each of these individual factors equal to 0, and then solve for x. So 2x minus 1 equals 0, and x minus 4 equals 0. That x minus 4 equals 0 is what gave us our whole number solution when we solved this graphically. I can add 4 to both sides and get x equals 4. 2x minus 1 equals 0 is the factor that's going to give us our fraction solution. I can add 1 to both sides to get 2x equals 1, and then divide both sides by 2 to get that x is equal to 1/2. Did I do it? Did I solve this system of equations? Not yet. Don't forget that every solution to a system of equations has to involve both an x and a y value. In order to find the y value that goes with this x equals 1/2, we can take that x value of 1/2 and plug it back into our original equations. Between these two equations, it's definitely easier to plug into y equals x plus 2. So let's do that. We've got y equals x plus 2, and we know x is 1/2. So if we plug that in, we've got y equals 1/2 plus 2. 1/2 plus 2 is 2.5, so y is equal to 2 1/2. I'm just going to write it as 2.5 instead of fighting to write a fraction. So we found our missing solution. The other solution to this system of equations is 1/2 and 2.5. All right, that was a lengthy process, but we did it. We did say that we could solve this system of equations by factoring or by the quadratic formula. If you thought that that factoring process was tricky, you might feel that the quadratic formula is an easier way to solve a system of equations like this, and that's fine. The first 3 steps are the same. We're setting the equations equal so that they each say y equals, then we're setting those other 2 pieces of the equation equal to each other, and then we're bringing that equation to standard form. Now that we've done that, let's pull out our a, b, and c values and plug them into the quadratic formula. A equals 2, b equals negative 9, and c equals 4. We know our quadratic formula, which luckily we don't have to memorize, is x equals negative b plus or minus radical b squared minus 4ac all over 2a. So let's start plugging those variables in. X equals negative 9 is positive 9, plus or minus the square root of negative 9 squared, minus 4 times 2 times 4, all over 2 times a, so 2 times 2. When we go to solve a quadratic formula, we're always going to start with that value inside of the radical. It's called the discriminant. We're going to simplify that discriminant first. So negative 9 squared is 81 minus 4 times 2 times 4 is 49. So under my radical, I've got 49, and I can also pretty quickly simplify 2 times 2 gives me 4. That works out pretty nicely. We've got the square root of 49, which is a perfect square. So the square root of 49 is just 7, and we don't have to mess around with simplifying a radical. We can rewrite this, and we're going to break this equation now into its two separate solutions, which are going to be 9 plus 7 over 4 and 9 minus 7 over 4. So let's solve those two fractions. 9 plus 7 is 16, and 16 divided by 4 is 4. So that's where our x equals 4 came from again. 9 minus 7 is equal to 2. 2 divided by 4 is a half. So there's our other solution. X equals a half. Just like when we factored, we still have to go ahead and use this x value to find the y value of our solution as well. And that step remains the same. We'll take that x value, we'll plug it back into the original equation, and say y equals a half plus 2, so y equals 2 and a half. All right, we've solved that system of equations pretty thoroughly. Your turn. Go ahead and pause this video and try solving the system y equals 3x minus 6 and y equals x squared minus x minus 6. Feel free to use either the quadratic formula or factoring, whatever seems easier to you. Example 3. Y equals 2x squared plus 2x plus 3, and y minus x equals 3. So we've got another system here that we want to solve algebraically, but this time we've got an extra step. This second equation is not set to y equals yet. So in order to get it set to y equals, we need to use inverse operations to cancel out that negative x on the left side of the equation. Let's add x to both sides, and that gives us y equals x plus 3. Now we've got two equations that are set to y equals. We've got y equals 2x squared plus 2x plus 3, and we've got y equals x plus 3. Take a moment with these two equations and see if on your own you can run through these remaining three steps and find a solution. And now try it one more time from the top. System of equations is y equals x squared minus 4x plus 9, and y minus 1 equals 2x. Run through all four steps and find the solution or solutions to this system.